Bismillahirrahmanirrahim. Hello my friends. Today we have a new lesson of the internal combustion engine, and it's one of the most important parts in the diesel engines. It's called the lubricating system, as shown in this figure. The life of any engine largely depends on its lubricating and cooling system. If an engine doesn't have a supply of oil or cannot be a high temperature or cannot ride itself of high temperature, it will be destroyed adequately and quickly. An engine's lubricating system does several important things. It holds an adequate supply of the oil to cool and clean and lubricating to save the engine. It also removes the contaminants of the from oil and delivers oil into all necessary area of the engine. Each moving part in the engine needs lubricating oil. The system that moves the oil through the engine is called the lubricating system that today we will talk about. Functions of the lubricating system. What's the functions of the lubricating system? The main functions of the engine lubricating system are as the follows. 1. To reduce friction and wear between moving parts. Moving parts like the piston and crankshaft and the gear and flywheel and etc. 2. Helps transfer heat and cool engine parts. When the engine parts components like piston move up and down, it causes the high temperature. The oil is make a cooling for this part. 3. Cleans the inside of the engine by removing contaminants like metal, dirt, plastic, rubber, and other particles. 4. To provide steering action. For example, the lubricating oil helps the piston rings into maintaining the effective seal against the high pressure gases in the cylinder from leaking out into the crankcase. 5. Absorbs shocks between moving parts to quiet engine operation and increase engine life. 6. Improve the efficiency of the machine. The lubricating system improves the efficiency of machine by increasing the life. Classifications of lubricants. There are many types of lubricants. 1. Animal lubricants. Examples of animal lubricants are tallow oil, lard oil, neat's foot oil, sperms, and rubber-based oil. This high, stable, and normal temperature animal lubricants may not be used for internal combustion engine because they produce fatty acids. 2. Mineral lubricants. These lubricants are used to a large extent and lubricant of aircraft internal combustion engine, created by refining crude oil from oil deposits in air. Methods of lubricants oil system. 1. Wet sump lubricating system. In the wet sump system, the bottom of the crankcase contains of oil sump, like in these pictures. This oil sump or the oil tank. In this one, the bottom of the crankcase contains oil sump or that serves the oil supply reservoir. The oil deriving from the cylinders and bearings flow by the gravity back into wet sump where it's packed and by a pump and reused or recirculated through the engine lubricating system. The types of wet sums used as the are as these pictures. The oil it's go from the oil tank or the oil reservoir. It's go into the oil parts or moving parts in the engine by oil pump, oil pressure pump in this picture, and it's back into the oil sump and recirculating use again in the engine. One of the wet sump lubricating system. One, there are splash lubricating system. In the splash lubricating system, oil is splashed up as shown in this picture. Oil is splashed up by the gear pump and oil is splashed up from the oil pan or oil trays in the lower parts of the crankcase. The oil is thrown upward. The oil is thrown upward as deposits or fine mist and provides adequate lubrication to valve, mechanism, piston, and binds, cylinder walls, and piston rings in the engine. Deburrs the connecting rod bearings caps enter the oil pan with each crankshaft revolution to produce the oil splash. A passage is drilled in each connecting rod from the dipper into the bearing to ensure lubricating. By moving the crankshaft and moving the gear pump, it splashes into every moving part in the engine. The connecting rod from the dipper into the bearing to ensure lubrication. This system is too uncertain for automotive applications. One reason is that the level of the oil in the crankcase will greatly vary and the amount of lubricating received by the engine. A high level results in excess lubrication and oil consumption, and slightly low level results in inadequate lubricating and failure of the engine. The precious oil that lubricates the connecting rod and bearings go onto the lubricants, the piston and walls by squirting out through structurally drilled holes. This lubricating system is used in virtually all engines that are equipped with semi-floating piston pins. Combustion, splash and force feed. In a combustion, splash and force feed, oil is delivered into some body of the means of spillage to other parts through oil passage under pressure from the oil pump. The oil from the pump enters the oil galleries and bearing and camshaft bearing. The main bearings have oil feed holes or grooves to pass the oil as is sure oil passage. And some engines use small throats under each connecting rod that are kept filled by small nozzle with delivered oil under pressure from the oil pump. If a combination system is used in overhead valve engine, the upper valve train is lubricated by pressure from the pump. As shown, the oil pressure pump moves the oil into every each piston pin and piston wall and every wall. Oil or the properties of lubricating oil. What are the properties of the lubricating oil? The oil used in an engine must serve a lubricant, coolant, and agent of removing impurities. It must be able to withstand high temperature without breaking down. The oil must operate over a good range of temperature. They must not oxidize the chamber wall. piston crown or at the piston rings. Oil should have a high film strength to prevent metal-to-metal contact even under extreme loads. 1. One of the properties of lubricants oil is oil viscosity. The viscosity of the is the resistance to flow of oil. The lubricating oil should have the correct viscosity so that it flows easily to all the moving parts. If oil viscosity is too high, more work is required to pump and it's to share it between moving parts. This results in greater friction work, reduced brake work, and hence reduce the power output. It's highly dependent on temperature, increasing with decreasing temperature. The fuel consumption may increase by as much as 50-100%, measured in cents or millimeters per second. Oil viscosity, also called oil weight, is the thickness of fluidity. The fluidity is flowability of the high oil. High viscosity oil is very thick and resists flow. Low viscosity oil is very thin and flow easily. Oils are graded according to their viscosity by a series of Society of Automotive Engines or SAE numbers. The viscosity of the increasing oil progressively with the SAE numbers. The viscosity of the oil in use is internal combustion engine rings from SAE Arctic use to 600 diesel use. It should be noted the SAE number of the oil has nothing to do with the quality of the oil. 3. Viscosity index. The measure of oil ability to resist the change in viscosity when subject to change in temperature. As temperature increase, viscosity decrease. 3. Flash point. This is the lowest temperature at which the vapor from a heated oil can ionate spontaneously on contact with the flame. The flash point of the oil is between 200 centigrade and 250 centigrade. 4. Specific gravity. Gravity, this property of the little importance except as an indicator of weight and volume. The specific gravity of the oil varies from 0.85 to 0.96. 5. Power point. It indicates the temperature below which the lubricating oil loses its fluidity and will not flow or recirculate in the system. This characteristic of the oil is important at low temperature. Power point must be at least 150 Fahrenheit, lower than the operating temperature to ensure maximum circulation. 6. Oxidation stability. Oxidation stability is oil its resistance to oxidation. Due to oxidation, oil forms deposits on the piston rings. The turbine loses its lubricating property, some impurities, and it's used to counteract these changes. 7. Acidity and neutralization number. Number the lubricating is should have low acidity. The neutralization number is a measure of the acidic or alkalic contacts of the oil. 8. Oiliness. Oiliness is responsible for the boundary line of molecules of the can adhere or cling to a metal surface or to providing lubrication after most the oil gets displaced or squeezed out. Oil additives. What is the oil additives? Special chemical coats additives are added into the base oil by oil companies. Different combinations different combinations of these additives allow the oil to do different scope in an engine. A description of common additives as follows in these pictures. 1. Viscosity index improver. An additive it helps to reduce the change in viscosity as the temperature of the oil changes. Viscosity index improves also keeps the engine oil from becoming too thin during the hot operation. 2. Friction modifier alters coefficient of friction alters coefficient of friction organic fatty acid and animals. The large oil high molecular and weight organic phosphoric. Oxidation inhibitor stop very hot oil from combining with oxygen in the air to produce acetylene trolac material which is cause bars and clogs the oil galleries and drain back passage oil or drilled into the engine block and head. 4. Corrosion and rust inhibitor. The prevent corrosion and resulting the metallic parts in contact with lubricants. Now we talk about lubricating system components or oil system components. You must remember that the lubricating system is actually an internal part of the engine, as the operation of one depends on the operation of the other. Thus, the lubricating system in actual practice cannot be considered as a separate and independent system. It's a part of the engine and main part of the engine. 1. The part 1 of the oil system is oil pan or oil reservoir. The oil pan is normally made of thin sheet metal or aluminium. It's made of sheet metal or aluminium and bolts to the bottom of the engine block as shown in this picture. It holds a supply of the oil for the lubricating system. The oil pan is fitted with a screw-in drain plugs for oil changes. Baffles may be used to keep the oil from splashing and the oil pan. The sump is the lowest area in the oil pan where oil collects as oil drains from the engine. When the oil is back from the engine, it's go into the oil sump. The oil sump is the main part in the lowest part in the engine or the oil reservoir. Then the oil pump can pull oil out of the pan for recirculation once again. 2. The oil pump. The oil pump is the heart of the lubricating system. It forces the oil out of the oil pan through the oil filter and galleries or oil galleries and the engine bearings. Normally, a gear on the engine camshaft drives the oil pump. However, a cog belt or direct connection with the end of the camshaft or crankshaft drives the pump in some cases. There are two basic types of oil pump, rotary and gear pump. Depressing in the outer rotor, the inner rotor of the center from the outer rotor. As the oil pump shaft turns, the inner rotor causes the outer rotor to spin. The accurate action of the two courses from box that change the side. A large pocket formed of the inlet side of the pump. As the rotor turns, the oil field becomes smaller and nearest outlet of the pump. Pressure relief valve. The pressure relief valve is a spring-loaded bypass valve in the oil pump engine block or oil filtered housing. The valve consists of a small piston, spring, and cylinder. Under normal pressure conditions, the springs hold the relief valve closed. All the oils from the oil pump flows into the oil galleries and the bearings. However, under abnormally high oil pressure conditions, cold thick oil, for example, the pressure relief valve opens. Oil pressure pushes the small piston back and its cylinder by overcoming spring tension. This allows some oil to bypass the main oil galleries and pour back into the oil pan. Most of the oil still flow into the bearings and present pressure is maintained. Some pressure relief valves are adjustable by turning a bolt of a screw by changing springs shim thickness. You can alter the pressure setting. 3. Oil filter. The oil filter removes most of the impurities that have been picked up by the oil as it circulates through the engine. This oil filter is designed to be replaced readily. The filter is mounted at an accessible location outside of the engine. There are two types of filter: full flow filters and bypass filters. The full flow system is the most common. All oil in a flow system is circulated through the filter before it reaches the engine, while the bypass system drives only a small quantity of the oil in each time it's circulated and returns directly into the oil pan after it's filtered. This type of system doesn't filter the oil before it's sent into the engine. The oil from the main oil gallery enters the filter and flows through the filter elements. It then passes into the collector in the center of the filter. The filtered oil then flows out restrict outlet, preventing the losses of pressure. Then the oil it returns directly into the oil pan. Oil pressure gauge is the 4 bar. The oil pressure gauge is mounted on the instrument panel of the vehicle, marked off and dialed in pounds per square inch or PSI. The gauge indicates how regularly and eventually the oil being delivered into all the virtual parts of the engine and warns of any stopping in this delivery. Pressure gauge may be electrical or mechanical. In the mechanical type, the gauge on the instrument panels is connected into an oil line tapped into oil galleries leading from the pump. The pressure of the oil in the system acts a diagram within the gauge, causing the needle to register of the dial. In the electrical type, oil pressure operates a rheostat connected into the engine that signals electrically to the pressure gauge indicating oil pressure within the system. 4 or 5. The oil cooler. The oil system engines requires an additional oil cooler to help lower and control the operating temperature of the engine oil. It consists of a radiator-like device called a heat exchanger connected into the lubricating system by the use of an oil cooler adapter. Oil is pumped through the cooler before it's put back into the engine. The heat exchanger pumped through the cooler before it's back into the engine. The heat exchanger looks like a small radiator that is fitted onto the vehicle in front of the radiator. Air flows across the pins of the heat exchanger, cooling the oil before it goes back into the engine. The oil cooler adapter is a device that fits between the filter and the oil filter housing. It prevents hose connecting for the oil lines and leading from the heat exchanger. Oil level gauge. The oil level gauge, also known as a dipstick, is usually of the deboned type of consists of the long rod or blade that extend into the oil pan. It's marked to show the level of the oil within the oil pan. Readings are taken by pulling the rod out from its normal place into the crankcase, wiping it clean, replacing it, and it's again removing and noting the height of the oil on the lower marked end. This should be done with the engine stopped unless the manufacturer recommends the other side. It's an important that is the oil level not drop below the low mark or rise above the full marks. Oil pressure warning light. The oil pressure warning light is used in place of a gauge on many vehicles. The oil warning light, also not as accurate, is valuable because of high visibility in the event of low oil pressure conditions, because the engine can fail or be damaged in less than a minute of operation without oil pressure. The warning light is used a backup for a gauge to attract instantly the attention to the malfunction. The warning light receives battery power through the ignition switch. The circuit to ground is complete through the oil pressure sends a unit that serves into the engine sensitive. All this about the lubricating system. Thank you for listening. Don't forget subscribe in my channel.